Good morning. I am Dr.P.SRI Devi. Today we are going to discuss about image encryption and compression. Information and communication technology are the backbone of today's digital world, and it has a broad impact on the human ways of communication. Huge amount of data is transferred every second. Lot of applications are developed based on internet like WhatsApp, Facebook, net banking, etc. Digital images are widely used in all these network applications. So image file requires more time than data file for transmission. Because of their larger size, it needs large storage devices and high bandwidth network system. So image compression reduces the size of an image file without affecting its quality by eliminating various types of redundancy such as coding redundancy, interpixel redundancy, and psychovisual redundancy. Lossy and lossless are the two types of image compression techniques. In lossless compression, the original image can be recovered exactly from the compressed image without any loss of data, which means the loss is very minimum. In lossy compression, some amount of data is lost in the reconstructed image. Run length encoding, Huffman coding, Lempel coding, arithmetic coding are the lossless compression techniques. So the image transfer mainly takes place over an unsecured network. Security is the major concern for any system to maintain the integrity, confidentiality, and authenticity. Image encryption is the process of converting the image data to coded form by applying mathematical algorithms. Hash function and cryptography are the different types of security methods used in image processing. Encryption provides security for image in storage and transmission. Both encryption and compression are needed for secure image transmission. So, it is necessary to propose a system that will include both security and compression. So, images need a high security in storage and transmission. Both encryption and compression are needed for secure image transmission. The combination of compression and encryption includes different categories based on their process sequence. Here the first one is encryption then compression. Encryption method followed by compression technique focuses more on image security than the reduction of the file size. The second one, compression then encryption. Compression followed by encryption method. Here encryption increases the size of the original image. It is not efficient from the compression point of view. So third one is compression and encryption in a single process. It provides a good image security with a low computational complexity. So this approach improves the shortcomings of previous two approaches. Previous two are ETC and CTE. But encryption then compression brings more attention in recent years due to the need of secure transmission in many applications. So orthogonal transformation and orthogonal transformation and linear operation ETC system which achieved a good compression with less security. Kinetic encryption with wavelet compression achieved reasonable level of compression and security with large computation time. So ETC system with arithmetic and Huffman compression with PECRP encryption resulted in good compression with less security. So PECRP encryption resulted in good compression, but it provides less security. So here we are using different dimension of images like 128, 256 and 512. In image encryption, original image is called plain image and the encrypted image is called cipher image. So according to the literature review point of view, the author Zarek Duda introduces asymmetric numeral system for data compression to combine the compression performance of arithmetic with the speed of Huffman compression, which attain good compression ratio. So in the same manner, kinetic encryption with the Colfitz attain high security. So the result from the recent studies show that the performance of ETC system still needs to be improved to meet the requirements in image compression and security. So a lot of issues like low security, transmission delay, low compression ratio, and the speed in encryption and compression algorithm afford a step to design a new encryption and compression system to provide a good compression and security during image transmission. So in the PECRP encryption, each pixel of the image one I is to be encrypted. A prediction is first made by using an image predictor gap GAP, a gradient adjusted predictor, which predicts the value at a pixel non-linearly by using its neighboring pixels. So the prediction error can be computed by the formula. For 8-bit images, the prediction error can take any values in the range -255 to 255. So all the mapped prediction errors of the image I are calculated. So after calculating the prediction error values, which are divided into L clusters based on adaptive approach, so it is necessary to divide the image into different blocks before applying random permutation. So clustering operation enhances the subsequent randomization and compression. The security and the encryption complexity are balanced by the selection of parameter L. So larger cluster provide a higher level of security, but it suffers higher complexity of encryption. So it is found that L equal to 16 is an appropriate choice for balancing the above two factors like security and complexity. So K is the cluster index. The prediction error in every cluster is resized into a two-dimensional block which have 4 columns and rows. Mod value of CK denote the number of prediction errors in CK. Here the cyclic shift operations are performed to each resulting prediction error block, and the data are read in a raster manner. A key can be either randomly generated or fixed. The values of prediction errors in each pixel position will be changed after permutation. So in the figure, the sequence is equal to S1, S2 up to S16, where the indexes of the elements of S denoted by the number numbers within the blocks. The key vector CS equal to 2301 specifies the column shift, and RS 1312 specifies the row shift. So the figure shows the entire encryption process of PSRP after prediction, mapping, clustering, and permutation. An assembler is used to concatenate all the clusters together to form an encrypted image. Entropy coding is a lossless compression method. Huffman and arithmetic compression are the widely used entropy coding methods. Asymmetric numeral method is introduced by Zarek Duda for data compression since 2014. ANM has similarities to range coding, but instead of encoding a symbol by choosing a range, the symbols are equally spread over the interval. Only one state is required to define the range. Here, in a standard binary numeral system, a bit of information from a digit, that is S belongs to 0, 1 is added to an existing number X, either to MSP or LSP, most significant position or least significant position. So in MSP, a new digit S can choose between ranges, and two numbers are required to represent the current state. A LSP, the current state is represented by a single natural number. The arithmetic compression uses nearly exact probabilities and gives good compression performance, but it takes large computation time. Huffman compression uses approximate probabilities with powers of 2, which leads to relatively low compression rates with high speed. But ANM operates on a state defined by a single natural number and uses least significant portion, LSP, which is the advantage of ANM. So ANM has the advantage of combining the compression ratio of arithmetic with the speed of Huffman compression. The natural number X contains log of X base 2 bits of information at symbols S of probability P. There is log 1 by P bits of information. So the basic idea of ANS is when a new symbol S is coded, log 1 by P bits of information will be added with log X of bits of information. Here X represents the appearance of corresponding even or odd bits, maybe S equal to 0 or S equal to 1. Here standard base 2 numeral system are taken. So set of natural numbers are divided into two subsets, U0 and U1. So suppose we are taking U0 2, 4, 6, U1 3, 5, 7, which corresponds to S equal to 0 and S equal to 1. Here we are updating X to X the appearance of S in corresponding subset. In the table gives the explanation. Here the sequence 0, 4, 1 is encoded into a natural number 47. So correspondingly S equal to 0, 1 to 2, then 2 to 5, 5 to 11, 5 to 23, then 23 to 47. And the same sequence 0, 1, 1, 1, 1 is encoded into natural number 18 by ANM compression. asymmetric binary system, asymmetric numeral system. Here we are considering base 4 numeral system. So the natural numbers are divided into two subsets, U0 and U1. Here U0 and U1 are 4, 8, 12, that is U0. U1 is 2, 3, 5, 6, 7, 9, which corresponds to s equal to 0 and 1. The table shows how we are calculating the values. Update x to x the appearance of a capital S in corresponding subset. The test data. So here we are using some performance metrics. Compression performance, mean square error, peak signal to noise ratio, computation time, and then NPCR, unified average changing intensity UACI. So those are all the compression metrics used to measure the performance of the entire system. A compression performance is measured in terms of bytes by using the formula bits per pixel. Bits per pixel, that is equal to size of compressed image in bits by number of pixels. So when the number of pixels remains unchanged, compression ratio can be related with bits per pixel. So compression ratio also defined by the formula bits per pixel of a size of uncompressed image by bits per pixel of size of compressed image. So compression performance, a table shows the compression performance. So we are taking some test data set. The data set is composed of 100 images with various characteristics. Out of that, 10 standard images with different dimensions are used to show the result. Compression performance is the measurement of number of bytes reduced from the original image. So in the table, ANM shows better performance for all the images than arithmetic and Huffman compression. So compression ratio, here the result show that the ANM compression has high compression ratio than arithmetic and Huffman compression. In this graph, names of compression images are plotted on x-axis and the average value of 100 images are plotted on the y-axis. We noted that ANM provides better compression performance than the arithmetic and Huffman compression. Mean square error. What is mean square error means? The quality of the reconstructed image is measured in terms of mean square error and PSNR value. Lower value of mean square error indicates the lower error. The mean square error represents the cumulative squared error between the compressed and original image. So a table shows the comparison of mean square error. The compression algorithm with high PSNR and low MSE, mean square error, high PSNR with low mean square error is considered as good compression algorithm. When mean square error is 0, original and reconstructed images are same. From the table values, it is clear that ANM gives lower value for mean square error, which indicates the lesser error. Peak signal to noise ratio, PSNR. PSNR is the measure of the peak error. PSNR is usually expressed in terms of logarithmic decibel scale. PSNR greater than 40 indicates better image quality. PSNR is infinity for lossless compression. From the table results, it is observed that the ANM gives high PSNR value. So table indicates ANM give high PSNR value. So ANM, Huffman compression, and arithmetic compression. So computation timetable shows the computation time of the method. The type of the type of processor, compression and encryption techniques are important for computational speed. A table shows that ANM takes less computation time than Huffman and arithmetic compression. From the chart, it is observed that the ANM compression produces high PSNR and low MSE mean square error value. The computation time also be slightly decreased by ANM. The number of pixel change rate is used to measure the change rate of number of pixels in cipher image, which is encrypted image, when only one bit of key or pixel is modified. The NPCR is given by the formula here. So USAI determines the average change in pixel intensities in corresponding position in the encrypted image as a percentage with F. The maximum supported pixel value F equal to 255 in grayscale images. It is defined by the formula which is given in the slide, where C1 and C2 represents pixel values of ciphered images at position ij. So the table comparison shows the difference between compression of NPCR and USCI values. So value that is for an 8-bit gray image, the optimum value of NPCR is 99.61, UACI is 33.46. So here NPCR and UACI values are 93.3 and 32.42, which indicates that PECRP has low security. So according to this discussion, the encryption then compression system with the ANM and PECRP encryption achieve high compression performance with related to high compression ratio, high PSNR and low mean square error value. So it achieves reasonable level of security, minimum reduction in computation time. So in this class, finally we conclude ETC system with the ANM and PECRP achieve high compression performance with a reasonable level of security. Thank you.